Okay, I need you guys to get out the Chapter 3, 1, 2, Logs and Exponential Evaluation Worksheet without a calculator. That was our last assignment that we had in here. Yes? Are we ready? Number 1, the answer is x equals 3. You good? Number 1 is 3, number 2 is 9, number 3 is negative 2, 4 is 3 over 2, 5 is 2, 6 is 1/2, 7 1/3, 8 is negative 11, 9 is 3 over 7. Number 10 is 4, 11 is negative 3, 12 is negative 4, 13 is negative 7, 14 is negative 3, 15 is 5, 16 is 6, 17 is 2/3, and 18 is 1/2. Turn it over. Number 19 is 14. 20 is 4. 21 is 18. 22 is 2. 23 is 256. 24 is 512. 25 is 1 over 100. 26 is 27. 27 is the square root of 7 over 7. If you got 1 over the square root of 7, you should have rationalized. Okay? Number 28, x equals negative 4. 29 is 3 over 2. 30 is 49. 31 is plus or minus 3 over 2. 32 is 60. 33 is 2. 34 is plus or minus 8. 35 is 4 over 3. And 36 is plus or minus 8. How did we do? Okay, let me answer a couple questions. I'm only going to do a few, okay? Because we did a lot of these in class that day. All right, problems 1 through 9. Mitchell? Number 8. Number 8, 1 over 32 raised to the x plus 2 power is equal to 1/8 raised to the x minus 4 power. Bless you. Okay, 1 over 32, how can I express 32 differently? What is 32? A number raised to a power? Well, obviously you can't start with 1 to a power, guys. So start with 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this is actually going to be 1 over 2 to the 5th raised to the x plus 2 power. That means this is 2 cubed raised to the x minus 4 power. Bring that to the top, that's 2 to the negative 5 raised to the x plus 2 power. 2 to the negative 3 raised to the x minus 4 power. Yes? So now my bases are the same, so I can cancel out those bases. And that implies that whenever I cancel those out, negative 5 times x plus 2 is equal to negative 3 times x minus 4. And you simply solve it from there. Yes? So this is negative 5x minus 10 equals negative 3x plus 12. Add the 3x. Add the 10. You're going to get a negative 2x is equal to a 22. So x is equal to negative 11. Do we understand number 8? Questions over 10 through 18? Number 15, log of the square root of 6 times 36 square roots of 6. Okay, immediately I'm going to make this equal to x. Why? Because I don't know what it is equal to. So I'm going to write this as an exponential function, and this is going to be the square root of 6 raised to the x power is equal to 36 times the square root of 6. Okay? Power over root. My power is a 1, my root is a 2, so this is 6 to the 1/2 x is equal to 36 is 6 squared times 6 to the 1/2. Yes? Now, what do I do with those two exponents? When the bases are attached by multiplication and they're the same, what do I do with the exponents? Add them. So that's going to give me 6 to the 1/2 x is equal to 6 to the 2½ power. These cancel out, and you're going to be left with 1/2 x is equal to 2½ What is 2½ equal to as an improper fraction? 5/2 multiplied by 2. X is equal to a 5. Yes? Okay, turn it over. Do we have questions over 19 through 27? 27. Okay, this says I'm going to have x raised to the -2 powers equal to 7. That's going to give me 1/x is equal squared is equal to 7/1. Why did I put that on the bottom? Because it has a negative exponent. So now cross multiply. I have 1 is equal to 7x squared divided by 7. 1/7 is equal to x squared. However, now what do I do to get rid of the power of 2? Take the square root. So if I take the square root of the top and the bottom, I'm going to have 1/7. The square root of 7 is equal to x. However, I can't have a radical in the denominator, so what do I have to do? Rationalize that, which means I'm multiplying by the square root of 7 over the square root of 7 to give me the square root of 7/7 is equal to x. Questions over 28 through 36. 35. Okay, I have to write this as a logarithm. I have to take it out of logarithm and write it as an exponential. So how do I write this as an exponential? Two to the 3x plus 1 is equal to 32. How do I rewrite 32? 2 to the 5th. Bases cancel out, so 3x plus 1 is equal to 5. Subtract the 1. 3x is equal to 4, so x is equal to 4/3. Yes? Now, I did a ton of these the day I taught this, didn't I? I did a ton of problems on this. And I've done at least 4 more today in class. This worksheet right here is your Part A test. Your Part A test is next week. Am I clear on that? Okay, put that away for now. You guys need to make sure that you correct that. Tonight's homework is going to be 3-2 worksheet. I'm passing it out to you right now. Okay, for the directions for 1 through 6, the directions say write the logarithmic equation in exponential form. So how do I write this in exponential form? (16) is the base of the logarithm, so it's the base of the exponential. Look across the equal sign and grab the 3/4 as the exponent, and that equals 8. Absolutely correct. Done. Number 6, same exact concept. What does ln stand for? Natural log. When you see ln, I need your brain to say log base e of 4 is equal to 1.386. So that's going to be e raised to the 1.386 is equal to 4. Do we understand that? Yes or no? That is how you're going to do problems 1 through 6. Next, 7 through 10. It says write the exponential equation in logarithmic form. So now I'm going the opposite way. I give the exponential, you write the logarithm. So how do I write 9 to the 3/2 is equal to 27 as a logarithm? log base 9, 27 equals 3 over 2. Very good. That is number 8. Huh? Yep. Number 10. That's going to be a log. What is my base? E of 4 is equal to x. Will I accept this on your test or on your homework? No. What is log base E going to be? That has to be ln of 4 is equal to x. Do we understand that, yes or no? Okay. That's that set of instructions. The next set of instructions says evaluate the function for the given value of x without using a calculator. That was the entire worksheet I just went over at the beginning of class. So what is f of x going to be? Nope. What's f of x also known as? Y is equal to log base 16. What's x going to say? What's x? 1/4. So now, how do I write this as an exponential? Bless you. 16 to the y is equal to 1 over 4. Now, I have to write these to have exactly the same base. So how can I rewrite 16? 4 squared sounds like a plan to me. So that's going to be 4 to the 2y is equal to, how can I rewrite 1/4? 4 to the negative what? Very good. So that gives me 2y is equal to negative 1, so y is equal to negative 1/2. Do we understand that, yes or no? Bases need to be the same to be able to do what I just did there. Are we good? Okay, next. Number 15, 14 and 15. It says describe the relationship between the graphs of f and g. What do we know about exponentials and logarithms? Or what? Reflections over what? Over the line y equals x. Which if you're a reflection of the line y equals x, that means that you are known as inverses. And we already found inverse functions previously. How did we find an inverse function before? We swapped x and y and solved for y. Remember that? Now, f of x is also known as y, so I have y is equal to e to the x. So now what we're going to do is we're going to rewrite g of x equals the natural log of x, because our brain does not think in logarithms. What does our brain think in naturally? Exponents. So we're going to rewrite this as an exponential function. So we're going to go ahead and make this a y is equal to the natural log of x. But we are going to swap out x and y. And the reason why we're going to swap x and y is because we are going to find our lovely inverse. Do we all understand that? So I'm going to make this x is equal to the natural log of y. So now I want you to rewrite this as an exponential function. So how would I rewrite this as an exponential function? Well, your brain needs to understand that natural log is log base e. So now what would be my lovely exponential function here? E to the x equals y. Does my blue box and my red box match? What that means is they are inverses. Do we understand that, yes or no? So that's how you're going to do problem number 14 as well. Any questions on the front page so far? Okay, the back page is where things get very complicated and hairy. Okay? So what we're going to do is we're going to do problem 16 first. We're going to do problem 16 first. So if I do problem 16, the directions say very clearly, find the domain, vertical asymptote, and x-intercept of the logarithmic function, then sketch the graph by hand, verify using your graphing calculator. Now, do you know how to graph logarithms by hand? No. What do you know how to graph by hand? Exponentials, right? So what you have to do is you basically have to find the inverse of this function. Graph that, and then swap out the ordered pairs to be able to graph the exponential, or to graph the logarithm, yes. So we're going to go ahead and make this a y is equal to log base 6 of x, and then we're going to swap x and y, and we're going to make that x is equal to log base 6 of y. So the inverse function that I need to graph is going to be 6 to the x is equal to y. That is the inverse. And the reason why we're doing the inverse is because if I can do an xy table to find my inverse, -2, -1, 0, 1, 2, yes? And that's going to be 6 to the -2, 6 to the -1, 6 to the 0, 6 to the 1, 6 to the second. That's 1 over 36, 1 over 6, 1, 6, and 36. Do we all understand that, yes or no? Now that means if I were to graph this, I would be graphing 0, 1, 1, 6, -1 and 1, 6, -2 and 1, 36. Do we see that green exponential function, yes or no? Okay, can you tell me about the domain of that function? Domain. It is increasing. You're correct. You're not wrong. It is increasing. So what's my domain? -infinity to +infinity. Yes? Which means if I'm doing log of 6x, that means my domain is going to be and range are going to be opposites of that. Yes? So if the domain of my exponential is -infinity to infinity, what's going to be my range of my logarithm? That's going to be -infinity to infinity because they have to swap. So now, I want to know what my asymptote is. Why am I asking for my asymptote before the range? Because that's what we did the entire time before, yes? What's my asymptote for my exponential? What is it never going to cross? It's never going to cross 0, so I have y equals 0, which means my range is going to be from 0 to infinity. Correct? Which means my domain is going to be from 0 to infinity for my logarithm, because they swap, don't they? You will not be able to do the black without doing the green. The black is the goal. Okay? Now, I also need to have my asymptote. My asymptote is going to be the opposite of what my asymptote is for my exponential. So what is the asymptote for my exponential? My asymptote for my exponential is right here, y equals 0. So instead of y equals 0, what's my asymptote going to be for my logarithm? X equals 0. Over on this one, I have a y-intercept being the point 0, 1. But over on this one, I'm going to have the opposite of a y-intercept, which is going to be an x-intercept. And what ordered pair will that be? 1, 0. Now, what I'm going to be graphing the ordered pairs that I'm going to be graphing is simply going to be swapping this, right? So I'm going to have 1 over 36 and -2, 1, 6, -1, 1, 0, 6, 1, and 36, 2. Do we all see that? So if I come over here and I graph those things, I'm going to have 1, 0, I'm going to have 136, sorry, and -2. I'm going to have -1 and 1, 6. Or I should say 1, 6 and -1. That puts me there. I'm going to have 6, 2, 4, 6, and 1. And I'm going to have 36 all the way over there. Do you see that graph? Mm-hmm. I did, but I was showing you what we were doing, okay? What I did here is I went ahead and I graphed this so that you could see it. Once you graph that, you should automatically come down here and do this XY table to get those points to graph it. Now, why did I do this part right here? I did the green, that part right there, so you could check it against this here, because they're going to be opposites of each other. You have to be able to get the black. On the test, I'm probably going to ask for all of it, so you better know how to get it. Okay, so that is number 16. Now, I did number 16 first because number 20 goes right into it. Why do I say 20 goes right into it? This is just going to be an up, down, left, right, stretch, compress concept, isn't it? So in this problem right here, I have f of x equals 6 plus the log base 6 of x minus 3, yes? So the very first thing I want you to do is find the exponential that you're going to be using. So the exponential you're going to be using, that means you have to swap out x and y. So this is y, so that means x is equal to 6 plus log base 6 of y minus 3. Because we're going to swap x and y, yes? I'm going to solve for y, so that means I'm going to subtract 6. Now how do I write this as an exponential? Now how do I solve for y? How do I solve for y? Now, you know what that means? If I look at these two graphs right here, if I look at this right here and compare it to this on number 20, what can you tell me? What's happening? I went right 6 and up 3. Do we all understand that? I went right 6 and up 3. So if I'm going right 6 and up 3, I should be able to take this entire XY table that we did, add 6 to the X value, add 3 to the Y value, and I have my new ordered pairs, don't I? So that means if I'm going to go right 6 and up 3, oh, come on. I am literally going to take negative 2 plus 6, negative 1 plus 6, 0 plus 6, 1 plus 6, 2 plus 6. Which means that's going to give me a 4, a 5, a 6, a 7, and an 8. Those are going to be my new X values. Does that make sense? If I'm going to go up 3 units, I'm going to take 1/36 and add 3. I'm going to take 1/6 and add 3. I'm going to take 1 and add 3. I'm going to take 6 and add 3. I'm going to take 36 and add 3. And that's going to give me the 3 and 1/36, 3 and 1/6, 4, 9, and 39. Make sense? So the ordered pairs that I would be graphing for my logarithm, I swap it. 3 and 1/36 goes with 4. 3 and 1/6 goes with 5. 4 goes to 6. 9 goes to 7. And 39 goes to 8. Those are the ordered pairs that you would be graphing. Does that make sense? Okay? Which means, if you think about this part right here, what did we physically do to this function? We went to the right 3 and we went up 6. Isn't that funny how it's the opposite for our exponentials? Do we get that? Which means my domain, my range, my asymptote is now going to be at x equals 3. Correct? Because that's my my horizontal shift changes my asymptote for my logarithm. Whenever I shift up and down for my exponential, that changes my asymptote. So this is going to be 3 to infinity, and this is going to be negative infinity to infinity. Now, how can I check all of this? When in doubt, graph it out. So I am going to graph this for you. So we're going to get a graph, and that's going to be 6 plus control 10 to the x. That's a base of 6. And this is going to be x minus 3, and hit enter. There's my function. You know what I want to do? I want to check my XY table. So if I hit Control T, Control T. If I check this, I should be able to get to know that it's undefined. There's my asymptote, right? Why do I have no graph below that? Why are there errors there? Because the graph doesn't even start until my asymptote, right? So then at 4, it goes to 6. 9 goes to 7. And now I have to come all the way down here to 39. 39 goes to 8. Is my graph right? Yeah, my graph is right. How do I find my x-intercept? You can do it by hand, letting y be 0, or you can do this on the graphing calculator. Menu, analyze graph, 0. And you're going to get 3, 1.28, and it's going to be scientific notation. What does that mean? What does that mean? If I'm trying to find an x-intercept, David, stand up. That means y is 0. So if I subtract that over and solve for this, that's 6 to the negative 6 is equal to log is equal to x minus 3, sorry. Six to the negative 6, what type of a number is that? Ridiculously small. Do we all understand that? David, stand up all the way. No leaning. I mean, you can do either one. What? Okay, I tried to do the harder ones for you. Here is the question of the hour. You have to make sure that you graph these. But I'm doing the exponentials so that you have an idea of where these come from. But when in doubt, graph it out and let the graphing calculator help you. Yes? Yeah. Okay. No, that's the air conditioner.